As you can see, I've rolled the helicopter outside for section 25, the rigging procedures. The reason being, we're going to have to swing the blade several times for the controls and pitch settings. Now, many of these details have been covered in the video and the manuals already, but we think it's imperative that we review this entire rigging procedure once again, just to make sure your helicopter is going to be safe. So the first thing we're going to do is start taking the panels off again.
Remove all the access body panels and the inspection covers. The battery should be disconnected at this time. The purpose of the tail boom is to hold the trim fins and the tail rotor in the desired location. If the trim fins and tail rotor are not in the proper location and set at the correct angle, the helicopter will not respond correctly in flight. To have the best stability, the following angles and distances must be correct. The angle of the top of the tail boom should be 2.5 degrees more than the angle of the square drive tubes in the airframe. The horizontal trim fin cord line should be parallel with the top of the tail boom. The vertical trim fin cord line should align 15 to 16 inches to the pilot side from the edge of the main shaft. To verify that the cord line of the horizontal trim fin is parallel with the top of the tail boom, follow the instructions in the manual and fabricate a small piece of wood. Sand or grind a small piece of wood to that thickness to be used as a spacer. Place the spacer on the trailing edge. Rest the level on the leading edge and the spacer. The level is now parallel with the cord line of the fin. Check that the cord line is parallel with the top of the tail boom. To verify that the vertical trim fin is at the correct angle, tape a piece of welding rod on the front and rear of the fin, extending about 1 inch. Clamp a piece of cardboard with an indicator of 15.5 inches to the pilot's side. Now, sight across the welding rods from behind the ship. The rods should align between 15 and 16 inches to the pilot's side of the main shaft. Level the main rotor shaft 90 degrees to the surface laterally and fore and aft. The purpose of the cyclic control is to maintain the balance of the helicopter when it's in the air by tilting the swash plate. If the angles are not within the specified range of travel, the sensitivity of the control will be affected, possibly to the extent of being unable to control the helicopter. The angles that will give the pilot the best control throughout all maneuvers are as follows. The total travel from the left to the right stops should be 52 degrees, with equal number of degrees both directions from the center position. The total travel from the rear to the front stop should be 52 degrees, with the rear stop set for pilot comfort. Note, the cyclic control must tip the swash plate to the correct angle in reference to the main shaft for proper control of the helicopter. Move the cyclic to the left and verify the stop is set and secured at 26 degrees. Move the cyclic to the right and set the stop at 26 degrees. Adjust the stop bolt so it makes contact with the cross shaft. Move the cyclic to the rear and set the stop at 26 degrees or less, for example, at 21 degrees for pilot comfort. Move the cyclic forward and set the stop at 26 degrees, or if adjusted for pilot comfort, at 31 degrees. Note, if adjusting for pilot comfort, the total arc must be 52 degrees. Adjust the stop bolts against the stop bracket as necessary. Check and set the swash plate to the correct angles as follows. Use 2 long 5/16 inch bolts and place in the lower pitch link bolt holes. Place the straight edge on the bolts. Set the rotating swash plate as shown. Place the level on the straight edge. Move the cyclic full left and full right. The level should read 5 to 5.5 degrees in each direction. Now, rotate the swash plate so the level is now in line with the center line of the helicopter. Check the swash plate angle, full forward and full aft. It should be 5 to 5.5 degrees, Adjust the male rod end as necessary. Once the cyclic controls have been rigged, install the cyclic inspection covers. Be sure the opening and the boot in the cover do not interfere with the full travel of the cyclic. The purpose of the collective is to control the amount of pitch on the main rotor blades and the amount of throttle on the engine, which determines how much lift you have to work with. To obtain the best control of both items, the pitch of the blades and throttle, the collective control must be set up as follows. Check the pitch on the main rotor blades. Set the cyclic laterally at 0. With the collective full down, both blades should be set at 1.8 degrees negative pitch. Check the pitch on the main rotor blades when the collective is in the full up position. The pitch should be 9.5 degrees to 10 degrees positive. In the unlikely event when the collective is at its stop in the up position and the pitch measures more than 10 degrees, it will be necessary to modify the stop on the airframe. Bolt a piece of shim stock to the bracket to adjust the correct pitch. This is necessary as too much pitch could produce low rotor RPM and blade stall. Check the teeter travel. It must be 7.25 degrees each way. Verify that the collective and the cyclic do not interfere with each other. Look closely at the pitch horn clevis and the rod end on the pitch links. They must have adequate clearance in all control positions. It may be necessary to file the clevis slightly so the rod end does not bind against the clevis opening. Also make sure the thrust blocks and blade straps do not interfere with the hub plate in all cyclic and collective control positions. The cyclic cables are to be adjusted with a bias. Using a spring scale, pull 4 pounds to align the rod end with the slot of the swash plate to give the correct bias on the control cables. The throttle is checked by placing the collective in the full down position and twisting the throttle from stop to stop. The throttle transfer rod should rest on the fore-aft throttle shaft at each end of travel. Collective full down and throttle off. The throttle should be adjusted so there is approximately 1/8 of an inch between cable housing and the aluminum barrel. The 3/16 inch hole in the eye bolt should be 1 inch to 1 1/16 inches from the rear of the collective cross shaft for proper correlation. The collective should travel a minimum of 16 inches from full down to full up position, measured from the center of the handle. The throttle cable should be checked and adjusted as follows. With the collective all the way down in the pocket, roll throttle completely off. Slowly lift the collective all the way to the upper stop. The throttle butterfly should not open. Adjust cable housing as necessary. Now with the collective in the hover position, rolling throttle all the way on should be able to obtain full throttle. The purpose of the anti-torque pedals is to control the pitch of the tail rotor blades. Changing the pitch on the tail rotor controls which way the helicopter will turn in a hover. To have enough control in all maneuvers and power settings, set the pedal travel as follows. The anti-torque pedal control should have freedom of travel from stop to stop, with the push-pull cable traveling 2 7/8 inches. Follow these steps when rigging the tail rotor. Reference construction print E17-2001 to fabricate a pitch checking template, using a 1/2 to 3/4 inch thick piece of wood as shown. Place the actuator arm in the full negative position. The arm should be very close to but not touching the tail boom. Now set the left pedal stop on the pilot side against the scissors. Set the left pedal stop on the passenger scissors. Place the jig on the blade end and set the negative pitch at 8 degrees. Rotate the tail rotor 180 degrees to check the other blade. Adjust both blades as close as possible to 8 degrees negative pitch, within 1/2 turn on the pitch link. After the negative adjustments are made, push the right pedal to its stop and check the pitch on both blades and verify that they are 24 degrees positive pitch. If the right pedal is at its stop and the pitch of the blades is more or less than 24 degrees, set the stop accordingly. If the right pedal is at its stop and the pitch of the blades is less than 24 degrees, recheck and verify the tail rotor cable range of travel is 2 7/8 inches. The rod end on the pitch horns should be centered over the 3/8 inch bolt holding the barrel to the shaft. Use washers if necessary to achieve this alignment. If more than 4 washers are required to position these rod ends, contact Rotorwake Technical Support. Safety wire the bolts of the tail rotor assembly as shown. The 2 bolts in the carriage slider can be safety wired to each other. Use a piece of heat shrink to prevent chafing. The main drive belts turn all the rotating parts in the helicopter. If the belts are dirty or loose, they will slip and the components will not turn at the correct speed. To verify the belts have been installed correctly, do the following. Verify the pulleys are properly aligned. Check that the main shaft is level. Level the engine flywheel, fore and aft, and by moving the top or bottom of the engine. Make a mark on the side of the engine pulley 200 thousandths from the top on both sides. This is necessary because the top of the pulley has approximately 200 thousandths more material above the belt grooves than the secondary pulley. Use a piece of bar stock as a straight edge and place it on top of the secondary pulley. The straight edge should be even with the mark on the engine pulley. Check the tension of the main drive belts. There should be 5/8 to 3/4 inches deflection with 7 pounds pressure from a spring tool. Check the tension of the fan countershaft drive belts. These belts must be tight to provide the correct RPM for the fan blade. Both belts should deflect 1/4 inch with a 10-pound pressure from a spring tool. Check the tension is correct on the tail rotor drive belt. The belt should have a tension of 1/2 inch deflection with 7 pounds of pressure. Check the tension of the alternator belt. It should be tight enough to turn the pulley by hand. Safety wire the adjustment strap bolt.